All right, now we're getting into problems that are a little bit more tricky in the sense that you need to isolate a variable before you can substitute it. Not that tricky. You can handle it. Let's see what we're going to do here. We have to solve each using substitution and then check the answer. I'm going to zoom in here. Oops, not what I wanted to do. I'm going to zoom in here on this one. And the first thing that I want to do is isolate the variable on the first equation. So what I'm going to do is say, okay, this says y minus 2x equals 3. I'm going to make a judgment that this is going to be the easiest thing to isolate because it's already down to a single variable. And the only thing that I need to do is add 2x to both sides. Then I get y equals 2x plus 3. That's what I'm going to use to substitute. So I'm going to take the other equation, 3x minus 2y equals 5. And where I see y, I'm going to substitute it with the algebraic expression that y is equal to. And in this case, as you can see just above, it's equal to 2x plus 3. Okay? So what we're looking at now is an equation in one variable and not two. When there's two variables, you can't ever nail one of them down to a certain number because if the other value changes, then the variable you're trying to solve for will change. So you always need to have a single variable in order to solve it. So now we do. We only have x. So now we simplify this and we say 3x. And now I'm going to distribute here and here. I'm going to multiply both of those things by that negative 2 that's out front. Okay, so I say negative 2 times 2x minus 4x. Negative 2 times 3, negative 6 equals 5. And now I'm at the step of combining like terms. 3x minus 4x is negative 1x, so I just call that negative x. Minus 6 equals 5, and I have to add 6 to both sides, and I get negative x is equal to 11. And of course, the number in front of x is negative 1, so I divide both sides by negative 1 in order to find out that x is equal to negative 11. Okay? So that's what we've done so far, and now we need to substitute that x equals negative 11 into the other equation, and we're going to use y minus 2x equals 3. So we say, okay, if y minus 2x equals 3 and x equals 11, then y minus 2, I'm sorry, x is negative 11, then I just want to get that, write that better. Sorry about that. So x is equal to negative 11, and actually I just want to use that when I'm subbing in, equals 3, and now we can say negative 2 times negative 11 is plus 22 equals 3. And of course, if we subtracted 22 from both sides, we would get y equals negative 19, and that will be the other variable. So we've solved for both variables. Now, I need to check my work, so I'm going to move this page up. You won't eventually be able to see the proof that I'm doing, but you'll be able to see it right now at the bottom. I'm going to draw a line. I'm going to do a proof. Okay, so let's draw a line and write proof. And what I'm going to do is I'm going to take each equation in turn, and I'm going to write it before subbing in. And what I want to do actually at the top, I just want to put right here our coordinates of negative 11 comma negative 19. Okay. And let's do y minus 2x equals 3. And down here, we'll do the other equation, which is 3x minus 2y equals 5. 3x, oops. Minus 2y equals 5. Okay, so starting here. By the way, let me know if you find it problematic that I'm zooming in and out. I don't know what it's like to experience that, except for when I'm doing this. But we've gotten the point negative 11 comma negative 19. So now we're going to substitute those numbers in where we see the variables. And we say y is negative 19, x is negative 11. And then when we solve this, we say negative 19. Negative 2 times negative 11 is plus 22. And when I combine these two, I get 3 equals 3. Check. That one works. So let's come down here and do this next one. We're going to write 3 parentheses minus 2 parentheses equals 5. And what is it? We have negative 11 for x, negative 19 for y, and when we calculate this out, we get negative 33 plus 38. Negative 2 times negative 19 is positive 38 equals 5. And negative 33 plus 38 is 5. So 5 equals 5. Check. So here's our original solution, where we substituted in, we first solved for y equals 2x plus 3, by adding 2x to both sides, and then we substitute what y is equal to in that equation, solving it all out to get x equals 11. Then we took the other equation, we put negative 11 for x, found y is negative 19, so we've got the coordinates negative 11 comma negative 19, and we just proofed them. Okay. Oops. So let's do that again for this one. And maybe it's better if I do it zoomed in large and then I do two sides of this. Let's see if I can do that. Okay, because I went off the page there a little bit. Now, what can we solve for? Well, let's take a look. If we solve this equation for y, all we have to do is subtract 3x from both sides, and we've got it to be y equals. So I'm going to take that. 18 equals 3x plus y, and subtract 3x, and I get negative 3x plus 18 equals y. Not sure why that moved. Okay. You could have also written that 18 minus 3x, it's the same thing, as long as the negative stays with the 3x, right? Okay, now we know what y is equal to, so I can then write this other equation here. 4x equals 3y minus 2, and I can substitute in for y what y is equal to. Y is equal to negative 3x plus 18 minus 2. Okay, and now we've only got a single variable. We can solve this. 4x equals, I need to distribute this through here and there, and we get negative 9x plus 54 minus 2. Okay, I'm going to add that 9x to both sides. Actually, you know what? Before I'm going to do that, I should always be combining like terms. Sorry about that. So these are like terms right here. And so I'm going to combine those constants. 4x equals negative 9x plus 52. Now I'm going to add 9x to both sides. and I get 13x equals 52, and 13x divided by 13 equals 52 divided by 13, and x equals 4. Aha! We've solved for x. And of course, we need to still solve for y, so what I think that we can do here is we can now take the other equation. We just used 4x equals 3y minus 2. We will now take this equation, 18 equals 3x plus y, and we will substitute x with 4. So 18 equals 3 times 4 plus y. Or 18 equals 12 plus y, taking 12 from both sides, we get y is equal to 6. So we have a set of coordinates 4, 6. Cool. Now I need to do the proof. So I need to actually, I can do something neat that I should be using more, is this tool where I can, let me undo that. I can grab a section of the screen and duplicate it. That, I can drag that down. I don't know if you can see that or not, but that allows me to now have the same equations down here. So that's kind of a neat trick. Okay, so, and in fact, let me do this one more way. I'm sorry, I hope you don't mind seeing that, but let me do this a different way. And I'm going to first grab one equation and then the other separately. And let's do that again. Okay, because having them separate allows me to, ooh, so sorry, not trying to do that. Allows me to substitute in better. You're seeing a lot of experimentation here. I hope you realize that I'm trying to do these videos for you, but I'm learning a lot in the process, and it's hard to learn new things and work out all the bugs off camera. Sometimes you just see all what's behind the curtain. Okay, so now I've got these equations, and I can then zoom in here and say 4 parentheses equals 3 parentheses minus 2. And of course, what goes in the parentheses? Well, x is equal to 6. I'm sorry, x is equal to 4, and y is equal to 6. And I'm going to do the same thing on this side, and then I'll solve them both. Okay, 18 equals 3 parentheses plus parentheses. And what do we get? Well, x is equal to 4, y is equal to 6. So let's solve these each in turn. 4 times 4 is 16, equals 18 minus 2, or 16 equals 16. Check. What about over here? 18 equals 3 times 4 is 12, 12 plus 6, 18, 12 plus 6 is 18. Check, this worked out. So that one worked. There's your solution. And we're going to do this one more time. I know this is a long video. You can scroll forward and as needed. But essentially that's what you need to do with these problems. So yes, this is one of these things is that this seems like a lot of work until you got to realize that I'm working with limited paper space, so it makes it a little bit more of a challenge in terms of how I lay it out. You can just be working down the page, and hopefully it makes it a little bit easier and quicker for you. But also, you get better at these over time. So if you struggle with these at first, don't worry, because you're going to work it out and get better over time. Now, okay, I'm going to use that trick I just used. I like that. I'm going to take my equations, copy them down here, and Do that one more time. Cool trick. Okay. Why do I care? Because what I want to do is I want to isolate a variable. And yes, I can divide both sides of this equation over here by 2 in order to get a single y, but I've already got a single x. It just happens to be negative. So watch what I'll do. I'm going to add x to both sides, and I get x plus 2 equals 2y. And then I'm going to subtract 2, minus 2. And I get x is equal to 2y minus 2. Great. So that I can, over here on this equation, I can write 23 is equal to 5y minus 4 times 2y minus 2. And then I can simplify this. So 23 equals 5y. I need to distribute this through. I need to multiply that and that both by that negative 4 that's out front. And I get negative 8y plus 8. Negative times negative is positive. And the first thing I want to do is combine like terms. What are like terms? These two, 5y and the negative 8y, they're both y terms. So 23 equals negative 3y plus 8. And of course, I will then be able to subtract 8 from both sides, and I get 15 is equal to negative 3y. And dividing by the coefficient of the variable, so I get down to a single y. I divide by negative 3, and I get negative 5 is equal to y. Okay. Now, I can go back to my original equation, the other original equation, and I'm going to just grab it again, like that. Drop it there. And I'm going to say, now that I know what y is, it's equal to negative 5, I can say 2 equals 2 parentheses, negative 5 minus x. Or 2 equals negative 10 minus x plus 10 plus 10. You get 12 equals negative x. And of course, we need to divide both sides by negative 1. And we get negative 12 equals x. So we've got a set of points in x and y. Negative 12, comma, negative 5. And of course, we need to do proofs for those. So what I'm going to do is I'm going to draw a line here. And I'm going to go up top, and I'm going to grab each one of these equations. Sorry about that. I'm not sure. Didn't mean to do that. I'm going to grab each of these equations there. Drop that down there. Do it again. So that below here, when we take those two values, negative 12 and negative 5, we can sub them in. And see how we do. 23 equals 5 parentheses, y is negative 5, minus 4 parentheses, negative 12. And actually, trying to always use red when I'm substituting in. I don't know why, just feel like it's helpful to make it stand out. And x is negative 12. Okay, so I want to simplify it. 23 equals negative 25, and negative times negative is positive, plus 48. Okay, 23 equals, this is where you need to actually do the calculations. You're doing 48 plus negative 25 or 48 minus 25. just to be sure that that's the right number. And look at it, it is. Okay, I'm going to erase that. Let's just write 23, but make sure you're actually doing the calculations. Don't assume that it should equal 23, so therefore you're going to write 23, because that's where a proof will fall apart, where you didn't actually prove it. You didn't go and do the math to make sure that it really does work out the way you're hoping it does. Okay, so be careful with that. 2 equals 2 parentheses minus parentheses. And what do we got? We've got, for y, we've got -5. For x, we've got -12. And we get 2 equals -10. Negative of -12 is +12. So we get 2 equals -10 plus 12 is 2. And both of these, check. They worked out. That means that our proof was correct. So, I'm sorry you can't see the proof on number 17, but here is all of that work that shows all of the things. I'm learning and getting better. Each time I get new problem types, I don't know exactly how to do it. Actually, what I've realized is that I can scroll over to different pages, and I might start doing that. So this is a long video. I apologize. It's take a while to upload, and it'll take a while to watch, but hopefully it's helpful. Okay, I'm done talking at you. Thanks.